Hello. My name is Christoph Langer. So I'm the second in the row of three guys from SAP speaking here. So the one or the other might know me from the OpenJDK community. You might see me on the mailing list. I try to support Andrew in maintaining the JDK 11 updates release. I think that's most of the work, which takes most of my time, what I'm doing in OpenJDK at the moment. So it's doing a lot of testing, integration, and so on. But today, I actually have the pleasure to talk about the work of my colleagues, namely Götz Lindenmeier, who more or less did all the progress to bring this into OpenJDK. But he decided to go surfing in South Africa. Usually he's here, but this year, so the turn is on me. Okay, so as it's already a bit late, so the brains have been wrenched a little bit over the day. It's maybe not the most sophisticated topic of the day, or at least not from how it looks like, because I mean, a little null pointer exception, it's not too complicated, just a little sentence that everybody can understand. But okay, there's some logic behind it, which is really quite some algorithm, let's say. So we come to that later. So what I'm going to cover, I start with how helpful are the null pointer exceptions currently, how helpful could they be. So taking an example as motivation. Talk about what we did, what we brought to the OpenJDK, where we are there. And then it's FOSDEM, so we talk technical, try to explain the algorithm behind it a little bit. And in the end, there are a few things which still can be done and could maybe leverage this. So I'll come to that in the end. Okay, how helpful are null pointer exceptions? So imagine this little code snippet. So I cut and pasted it out of some source code, line 33 we see. Some object with fields, and there's another field, has some payload. There's an assignment to this payload field from another chain of object fields. So what would we get currently? We get something saying exception in thread main, null pointer exception. Okay, we see the file name and the line, like line 33. But wouldn't it be nice if we knew what's the field that's null here? Yeah? Okay, so could be like this, huh? So it tells cannot read field D because A2.B.C is null. So we know, okay, it was exactly this guy here. Okay, obviously the null pointer exception could look like this. So this is what we contributed to the OpenJDK. Actually, the thing behind it was already implemented years ago by colleagues for our commercial edition of the JDK. It's called sub-JVM, but only the SAP customers using SAP products based on Java could benefit of it. But we were quite sure that it works, at least. And so last year, about shortly after FOSDEM, I think, the initial mail got proposed it on the mailing list. Just said, okay, it's a little enhancement, cannot be that thing. And this proposal was welcomed by people, obviously by the developers of Java, and people saying, sure, about time to have it in. But it was challenged too, because out of several reasons. So one thing is always, okay, you don't maybe want to have too much information in exception messages, because you don't want to leak too much data to maybe some attacker or so who can then read something. So maybe that's a concern. Then one thing is performance. So we don't have negative performance impact by such computation of messages here. And then it was also about the approach. So we did this really in the hotspot VM coding in C++. So people stepped up and said, hey, can we have a look? Maybe we can do it in Java with bytecode APIs and stack walking APIs, etc. But okay, that was part of the discussion. And I don't know, it evolved. Then people from Oracle came up, and I think they motivated Götz to make it a JEP. And with the help from, I think, Colleen, Alex Buckley, and so on. So we brought it to a point where it was admitted to JDK 14, and we could push this to right in time for JDK 14 in October last year. So it's available, but it's not the default. So you have to use this flag to activate it. Otherwise, you will still see the old scarce message. But yeah, you can switch it on. And we, for the submachine binary distribution, we switched it on by default, so we are confident in it. And we also backported it to submachine 11 edition. So if you want to try with JDK 11, you can use submachine and you don't need an additional flag. But I guess, I don't know, we can also discuss about backporting it to OpenJDK 11 if there's interest. Okay, so yeah, some technical insights. The null pointer exception message, you see the green line. It says cannot read field D because a2.b.c is null. It has two parts. So the first part is what went wrong, cannot read field D. And the second part, that's the more complicated part, I'd say. You have to go back in the program flow a bit to figure out what exactly was the reason what brought the null reference onto the operand stack. And it's also important, at the time we can create the message. We have a bytecode index of where we are at the method. As we are in hotspot VM, we can query for the bytecode for the constant pool. But we don't have the program data at that moment. We have no variable constants or things like that. So we have to live with what we have here. Okay, so then let's take some simple example. So really an easy thing. You initialize an object with null and invoke the method toString on it, on this null reference. So you will get a null pointer exception. So this in bytecode will work like this. So at first you have the aconst null instruction. This pushes the null reference on the operand stack. So basically Java bytecodes, I know maybe people are not so familiar with it. It works like the instructions, they push and pop things on an operand stack, and it's defined for each bytecode what it's expected before on the operand stack and how would it look like in the end, what arguments are popped and what's pushed there. So okay, so to do an object initialization, you will obviously at first then load the null. You initialize a local variable slot, the slot 1, with the a*1 instruction that pops the null reference from the operand stack and it's stored in this slot. Okay, that was the first line of the example. Then the second line does a load 1. It loads again from this slot of the variable, pushes the value on the stack. So yeah, we had it initialized with null, so there will be a null on the stack. And then we try to invoke the toString method with invoke virtual instruction. Yeah, afterwards the reference will be gone, but in our case we get a null pointer exception because it was null. The method we try to invoke, the object we try to invoke the method on. Okay, and now from the failing bytecodes we can generate this textual message about the failed operation. For the cause we have to walk back, as I said. And so that's what this algorithm starts with, is really to replay all this from the entry to the method until the point where the null pointer exception happened. That we have for each bytecode, we have a representation of this operand stack. And then from this operand stack, we have backlinks for each field to the instruction which pushed the value there. And so then that helps us to then walk and generate the message. Okay, so part A, what bytecode fails? Not every bytecode can cause a null pointer exception. So we have here the array operations. So if the array you want to access is null, then you can say something like cannot load from int array, for instance, element type. So or the array length cannot read the array length. The get field and put field instruction I cannot read. I cannot assign a field. Ideally, we also have the field name from the constant pool here. Those invoke instructions, like we saw here, the message would be cannot invoke a method. Throwing exceptions and entering and exiting monitors, they also need objects. So yeah, that's a simple switch statement on this bytecode, like here the invoke virtual, and we come to this part A of the message. Okay, then for the second part, the because, why the null pointer exception was pushed. There's a little bit more to be done here. Okay, in the easy case, you have something like a const null. Okay, then we can only say null is null, sure. There are constant operations, so we know the constant that is pushed on the stack. We can just name it. So for an array, we do two things. So at first we go back the path for the bytecode that pushed the array reference. So this could also come from another field, like in the example I had, like several field references. So we really have to go recursively back until the point where we started at. Okay, then we have the brackets, and then we also write something about who put the index there. Yeah? Okay, so get field. Get field, we can write the field name, but then we have to get also the cause for the reference that the get field was invoked. Get static, there we have class name and field name. That's the easy thing. So those invoke instructions. So that's when methods are called. Then we can say, okay, the return value of the method is, or in some places we would only give method names, like in the index computations of the array accesses. And then the load instructions for loading and storing variables. Okay, so in our case, it was an A load, which put the null reference on the stack. And the A load comes from the variable object. And so then we can say, okay, cannot invoke object because object is null. Okay, so yeah, there are some more things I want to mention here about this. So one thing is this calculation of the message is only done when we invoke the getMessage method of an exception. So at the time the VM generates such an exception, it really just stores the bytecode, the stack information as it did before. So no change about that. And only when somebody calls like print stack trace or so, it will call getMessage, and then we would do all this. So in the usual flow of Java VM, you should not see an impact because, I mean, exceptions get thrown, get caught, and not necessarily printed out messages. Yeah. Okay, and the first thing was, it's also, we are talking only about the messages generated by the VM itself. So there's also possible, like I can do a new null pointer exception, construct an exception, but here, yeah, then the developer knows what he's doing. He would probably also enter a meaningful message already. So okay, we won't capture this. Then there's something like hidden frames. For instance, when you have lambdas and then there are some frames put in by Java C and the VM. So those stack frames are tagged hidden. So if we hit a null pointer exception there, then we would not generate a message because it's probably not so meaningful to people looking at the exception. Then the point, it's implemented in the virtual machine, in the C++ code. Why did we do that? Yeah, the thing is we have really everything at hand. I mean, we are in the VM, we can query for the bytecodes, for the constant tool, for everything. And on the Java side, okay, there's a stack walker and there are also bytecode APIs, but it's more complicated to get all the data we need here. So I think it was really the best way. And in the end, I'll come to that. Yeah, we'll come in the end to that. Maybe by this algorithm or this bytecode class, we can leverage it for other exceptions as well. So, okay, then another point. The best results you will see obviously when you compile the Java class with the right debug settings. So default of Java C is only the lines and source information. So in the code stack you will get the line numbers and the source file, but you usually don't have the variables unless you compile with this -g flag or this -g vars line source, whatever you can specify. So once we have the variables, then we can print them in the message. If we don't have them, for locals, we have to print something like parameter 1, parameter 2 for the method. Or for local variables, it's even more complicated because then we only have slot numbers, and so it's not really accurate, or you don't know what the compiler does, where variables get allocated. Yeah, okay. So, yeah, things still to be done. So as I said, this feature is now kind of beta, it's disabled. So we are hoping to get this enabled by default one day. So maybe let's see how the feedback is, but we will try to ask the OpenJDK community if we can switch it on. Then there's something, objects require non-null. You might heard about that one. So this is some place, maybe also a means of tackling such null pointer exceptions. You can, before you call into another method, you can wrap it with a call to objects require non-null. Then at that place, before we actually enter the method, we check for the null. Then you have a defined place in the code where this could happen. Also, you would not go further down in the program and see the null pointer exception at places where you really don't want it. But on the other hand, then you lose this information, because this is then a null pointer exception that the developer has written or has constructed. So yeah, our thing is not applied then. Okay. Then there's this thing like single file source code mode. So there was JEP 330. You can now, you don't need to use a Java file, compile it and invoke Java with the class file, but you can go like in script mode or so, call Java with a .java file. And then you at the moment also don't have this those null pointer exceptions. It would also be nice to have it here. And what you can do is you can set the VM option by parameters to the Java, but you can't modify the compiler at the moment. You can't set the -g option to have the variables. So that's something where we have to find a solution. Then, okay, the JShell use case. I mean, that's really something where you want to go and just prototype something in JShell, and then it would also be nice to really get those null pointer exceptions here. So if we do the bullet 1 and enable it as default, then JShell will have it. Otherwise, at least maybe we can make it a default for JShell. And then there's another place where the algorithm might be applied. It's the array index out of bounds exception. I think we have some time left, so I can try to demo it. I've prepared a little prototype. Oh, actually, it was good. So, yeah. So you see here, it's a little test case where we do out of bounds accesses on arrays. Maybe we can also make it a bit bigger. Okay, so maybe we go even back to Java 8 time. So if I run it with JDK 11, so you see here, it only tells you the index, array index out of bound exception, index 5 in line 12. So okay, it's only one array, but if you have a chain of arrays, maybe like here, array 1, 2, -1. So okay, as we have here the -1 only in one place, we can guess it must have been this array access. Okay, then there's a little enhancement already, part of I don't know, was it 10 or 11, which was contributed by Götz. Was it more helpful, right? So we can see the index out of bounds for the length. So the array had only the length 4. It already helps a little bit more. And now if we use the same algorithm as in the null pointer exception, we go and this is IOB demo even more helpful. So we can really come to some statement about what index was it and the array name. Yeah. So that could leverage the feature too. So yeah. Okay, I think I'm at the end. So if you have questions, I'm happy to answer.
What's the question?
Hey, so one use case for which I think it's important to have better null pointer messages with respect to the objects required non-null is wherever, basically there are places where the JavaC compiler will insert those checks. I know at least 2 places. One is strings and switch, and the second is when you construct an inner class from an enclosing class instance. Mm-hmm. In these cases you can get a null pointer exception, but we won't get any benefit from this work because it's just an opaque call to require non-null.
Yeah. So for that, actually, I mean, Götz also did a prototype. I brought it here, so maybe we can can demonstrate it too. So that's this class. So okay, I mean it's really a constructed. I have to. Why doesn't it? I only have this presentation mode. It doesn't jump over.
We don't see the same.
Yeah, I know. That's what I'm trying to fix. Maybe we try this duplicate.
Yeah.
Yeah, okay. So yeah, this is this example here. Okay, it's a bit constructed. I mean, you have a chain of require non-nulls here, yeah. But here it would help because with the current thing, what is this? Requires no null, the standard thing. So again, I get only a null pointer exception, and yeah, I know it's like require non-null in require non-null, and it comes from my line 23 in main, which is this one. Oh, but which require non-null was it? And if we prototyped using the null pointer exception algorithm here, and so yeah, here we get some message like okay, it still occurs in require non-null, but as we know, this is this method. We can jump back the stack and then do this computation of the bytecode here and come to some explaining message. So that was just an initial approach. So I think it's about time that we can discuss it on a mailing list to refine it.
I have a question. You said you need to compile it with line information, with var information. What would the message look like if the var information is not compiled with?
There, I think I also have something here where I can like local param. Okay, yeah. Okay, so here we have a function call with a method parameter, and also we have a local. So I have to tell Eclipse to change the compilation. Java compiler, take this knob. Okay, and then we can run it with what is the np01? I always have problem local param here. Okay, yeah, here you see it. So it would tell you parameter 1. So this is okay, and then you have here local 2, I think, yeah. But local 2 is the slot number, because here in the I think the slot 0 is the this pointer to the object. 1 is used for the parameter index, and then the slot 2 is local index. So yeah, maybe we should rather say something like local slot or so, that for people analyzing this, it's clear it's not necessarily the local variable number 2, because here's only 1, but it's maps rather to the slot number. Yeah. Yeah. But still, I mean, there is more information than before.
Okay, one question. You have the information of the variable. Is there a way to get the class information? Which class is involved?
Yeah, I think we use it here. So in this example, like this. So, but the class information, that's easy. There you don't need to have the compiled with variable information, because the classes with their fields and their names, that's part of the constant pool at runtime. So that's easy.
I was just wondering, this would be a bit susceptible to damage if something bytecode transformed a method and injected code into it. Have you looked at what would happen if that was done? I'm not just thinking of something like Byteman, where I could probably break this very quickly, and it would be very rude of me to do so. But I was thinking where you've got code transformers like middleware that does changes to code. How much would that make this less meaningful, or do you know?
Actually, I don't know how much Götz has tested those cases. I mean, there are also things like it's not about Java. It's also like other languages or so which compile down to bytecode. So I would think it's still kind of useful to see more information, at least like before. But yeah, it's something to be evaluated probably. Yeah.
So you answered half of the question I was going to ask by showing the requires null thing. Why wouldn't we want to do that in all cases? If a null was passed in as an argument, walk back up until we get to a field load somewhere and say it came from this call further up the stack, and that's where that null actually boiled out and came into this method. Because right now, I think normally it's just local. The details are just local to the method, right?
Yeah. Yeah, maybe in the case where there's no custom message, which we don't want to override, yeah, maybe we can think about that. Yeah. Or maybe we can use an annotation or something where you want to see it, but then you have to annotate methods. So that was brought up in the discussion for this objects require non-null support, that would be one way to tackle it. But yeah.
Would it be able to tell me that the parameter or the local is an int in this case?
Again, the local is, yeah.
That the type of the variable, if I have like a bajillion locals, but each one has like the super long class name.
I think, yes, you have access to the signature of the method, so that should be possible. It gets more complicated with the stack slots again, because then you have wide slots or just one slot, it depends. So then it's a problem. But for the method signature, it should be there.
Quick question on the status. So you mentioned that you at a CB machine you have this in version 11.
Yeah.
I know that Red Hat, being a student of 11U, doesn't necessarily object to new features like Shenandoah being backported. I wonder if this is one of those JEPs that could be backported to 11 users.
Okay, I mean,
have you discussed this, or is this was
we
that?
discussed this, so we didn't bring it up to the table yet. I mean, we were just happy in October that okay, finally it's in. So let's settle it a bit. But okay, yeah, we can start.
I don't know if you can backport something like that though, because this does change things. Existing application may not spread those exceptions, isn't it?
Yeah, maybe so if we bring it to 11, it would be a good idea also to keep it under the flag and don't enable it by default, definitely.
By default or not?
No. Time's up.
So I implemented this in Android 5 years ago, or it became public 5 years ago, but not to the extent that you've done it here. And the biggest pain in getting this enabled was people who had unit tests where they would capture the exception and put it into a file. And then all of these golden file tests all broke.
Yes.
And you keep mentioning changing the message and things like that, and I just keep imagining all of these unit tests breaking and breaking again.
Yeah, that's maybe. I mean, even for the SAP machine, when we enabled it, we had to go and, I mean, we were running JEP rec tests regularly and some things, so we had to change a few places where the golden file had the simple null pointer exception. Yeah. Okay, so I think time's up. So thanks for a lot of questions.